we will see a demo video that how can a flat slab can be analyzed and designed by MMS programs. So first we will click analysis to draw the 2D frame. That is, we will be doing this analysis by equivalent frame method. Okay, so let us first draw the 2D frame for the flat slab. So we have to use the same program, that is for the analysis of 2D frame or folded plates or continuous beam, right? This can be used for frame of a flat slab also. If a flat slab is having non-rectangular sections, column sections such as circular columns, then you can use analysis of truss. This you can use this program, right? But we are having columns, all columns to be square, so we'll be using this program to do the analysis of a 2D flat slab frame. Okay, now let us draw a frame. Write the number of bays in the frame. The number of bays in the frame are 4. Now please use enter key to save the data. Enter. So write the number of story. Okay, say it is G plus 3, so we will write 4, because if it is only ground floor then you have to write 0 story. It is G plus 3, so we will write the number of stories equal to 3. Either press enter or click OK. Okay, write the typical height of the story, so it is 3.5 meters. Press enter. Write the width of the bay 1, 4 meters. Width of bay 2, 4 meters. Press enter. Width of bay 3, 4 meters. Press enter. Width of bay 4, 4 meters. Press enter. Right. So this is our 2D flat slab frame, which we will be designing by equivalent frame method, right? Okay, now are there any further member to be drawn? If you want to draw any members, then you can draw by giving the coordinates of the individual member. Okay, but we don't want to draw, we say no. Okay, click finish command. This page says how are the text box to be numbered. So frame joints are to be numbered first, supports joints are to be numbered at last. These are the frame joints, these are the support joints. So let us fill the text box first. Is the drawing complete? No, because we have to still fill the text box. Just click on the text box and the number will be populated. Say this is joint number 1, frame joint number 1, frame joint number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 is a support joint, 22 is a support joint, 23 is a support joint, 24 is a support joint, 25 is a support joint. Right, click finish, exit. Drawing is complete. Yes, the text box are filled. Write the total number of frame joints, 20. So write 20, press enter. Okay, write the total number of support joints, 1, 2, 3, 4, 5. 5, press enter. Okay, now support number 21 is fixed, 22 is fixed, 23 is fixed, 24 is fixed, 25 is fixed. Okay, so you can see all the text has been converted to blue because it is fixed support, right? Now let us give the data and the load to the frame. So there are two commands through which we can give the data. We will be using by mouse. Okay, this will be using this command. Okay, now width of the members. So this is a flat slab. So we are considering the width of the slab to be 3 meters. Okay, so write 3, click press enter. Okay, and let us select on and select all the slabs, right? Okay, so all the slabs are going to be assigned with a width of 3 meters assigned, right? Now let us assign the width to all the columns. Say all the columns are square columns of 0.45 meters by 0.45 meters. So let us take 0.45 meters and select all the columns, right? Select on. Okay, now let us assign the value of width to all the columns, right? Now let us give depth. Say all the depth of all the flat slab is 0.3 meters. 0.3 meters. Press enter and let us select the slabs. Okay, so let us assign the value of depth to the slab. Now depth of the column is again 0.45 meters. Press enter and let us select all the columns. Okay, let us assign the value of depth to all the columns, right? Now let us give a loading. Okay, say a UDL of 75 kilonewton per meter is acting on all the meter square. Okay, so is acting on all the slabs. Okay, press enter. Okay, and we can select all the slabs. Okay, now let us assign the value. You can see the loads UDL applied, right? Okay, now as the drawing is complete, save the file, right? Let it be saved as M. Okay, right. Now let us perform run analysis. Okay, this is a very important note made over here. For flat slabs, folded plates only run input. Okay, you do not have to run this run analysis command, because in case of flat slab, the stiffness factors are going to be changed, as we are going to have drops and capitals in a slab and columns. Okay, so we will be only creating input over here, right? Run input. Okay, you can see the output of the input if you want, right? Okay, now we will go to the program flat slab on the design page. Program list. Okay, so this is the program for flat slab, right? Right, we have to give two values over here. One is clear height of column. This is clear height of column. Okay, when there is no capital and no drop, then the clear height is actual clear height between the slabs. Okay, when you are providing a drop, then the clear height will be from the top of the slab to the bottom of the drop. Okay, when you are providing capital, then the clear height will be from the top of the slab, top of the bottom slab to the bottom of the capital. Okay, and the second is height, right? Height is measured from the center of the slab. Okay, center of the slab to the bottom of the capital, center of the slab to the bottom of the drop, or center of the slab to the bottom of the slab, right? So in our case, we have uh, the height of the slab from top to top as 3.5 meters. Okay, we are assuming we have given the depth of the slab as 0.3 meters, and we are assuming a drop of 0.125 meters. Okay, so the clear height, the clear length, sorry, turns out to be 3.075 meters, right? Press enter key. Height. Okay, height, whatever clear height you get over here, you have to add the 50% of half. You have to add half the slab thickness, that is 0.15 meters, right? So that is going to work out as 3.075 plus 0.125. Sorry, it is to be, the addition is has to be of 0.15, right? Okay, okay. So that turns out to be 3.225, right? Press enter. Okay, so by giving these two values, okay, the software will select the required stiffness factor as according to the stiffness of the joint, whether there is a capital or a drop. Okay, we are not, we are at present we are considering that there is no capital and there is only a drop. Okay, so after giving the values in the text box, now let's click finish. Are you sure no further editing is to be done? Yes. Okay, write the modulus of elasticity of material in kilonewton per meter square. We are assuming it as 2E8. Okay, this is just an assumption. Actually you have to take as according to the concrete mix. Okay, just press enter. Let's write the load factor is 1. Press enter. Load factor applied to the lateral load is again 1. Okay, press enter. We are considering drop, so we will write 1. Okay, and Fi is 415. Okay, FCK is 25, right? Click. Okay, finish. Okay, now you can see the analysis of the flat slab and the design of the flat slab. This is the analysis of the flat slab. Okay, on a particular member, what is the maximum axial force and what are the moments in the particular joint are shown over here. Okay, and this is the design of flat slab. Okay, and you can see that the moment and shear force at every 0.25 meters from the supports are shown over here, and the corresponding AST required in column strip and middle strip is also shown over here, right? Okay, now we can see the assumed depth fails in shear, so redo analysis for a new D written above, because loading due to dead weight has to be revised. Okay, so we had assumed the depth of the slab as 300, but this turning out to be more. It is required say around about 562. So this is how we see that the section has failed, right? So you have to uh, change the depth of the slab, and again do the uh, design, right? But please remember that after you get a correct section, right, then you have to recheck the section depth for punching shear, because this software only considers the punching shear due to the actual load, but not due to the additional uh, unbalanced moment which is distributed through punching shear, right? That I will show you in the figure. Okay, so this is how the analysis and the design is done. Okay, and we can see that the slab is found to be failed, slab is found to be slid. Okay, so the thickness of the slab has to be changed. Okay, but this video shows that how this program can be run. So the motive of this video is to show that how the program works, right? That is the flow of the program, right? Now, okay, so what I meant was that you have to check for the punching shear again, because say you will have some unbalanced moment over here, because say the moment over here will be say MA2 and over here say MA1, then the difference between these two is the unbalanced moment, which will be partially taken by the column and partially will be transferred by the punching shear, right? So you have to calculate this punching shear stress, additional punching shear stress that is to be added to the punching shear stress due to the force in the column. Okay, and then it has to be checked for the total shear, right? So that has to be rechecked manually, because this program does not take this additional this additional shear which comes due to the uh, unbalanced moment. Okay, so this is something to be remembered. So this is how you can do the design analysis and design of a flat slab. Thank you.